of just, let's say, um, helium. We know helium is a gas, but let's say hypothetically helium is a solid strata of rock in the earth. Well, the half-life of helium, if helium had a half-life, it would slowly decay into hydrogen. So you have a strata of pure helium, but when you check it, you will see over time that some X amount of the actual helium molecules have reverse transmuted into helium molecules. Into hydrogen molecules. And in that process, that's how scientists determine the age of the Earth. When scientists dig down into the Earth, every layer of strata in geography gives them a date. They can check the actual strata themselves and see, okay, this particular chemical compound is comprised of this, but there shouldn't be these chemical compounds. And since these chemical compounds are in here, this is giving us an idea of how old this compound is. As they go down into the Earth's geographical history, that is the process by which they use to determine the age of the Earth. They also use the same process to carbon date particular species. For instance, dinosaurs are found within a certain boundary of the geographical timeline on the whole planet Earth. The whole planet Earth, Africa, China, Japan, Australia, have the same stratas at the same locations physically. The actual composition of them may change, but the stratas themselves are constant with the geographical timeline. And this is how the scientists are able to utilize the information that is around them to determine the things in nature. The overall premise is that they are interpreting the information that they're observing in the rocks themselves. That's to say that they have to accept that hydrogen forms to higher level elements, and that the higher level elements, by way of transmutation, hydrogen forms the higher level elements, and by way of reverse transmutation, the higher elements can form the lower elements. Then scientists have to say, this particular chemical compound group is special. This particular chemical compound group is also special. So when this group is sitting on top of this group, they can conclude that this group was formed after this group relative to the location, because if lava flows down here, then when a lava flow, that's a chemical compound group. When another lava flow, that's another chemical compound group. Logically, the lava below top layer has to be older than this layer. So the layers at the very top are younger than the layers at the very bottom. And it's a law in geography, I just don't remember the name of it. They use this type of information to determine exactly to describe what they're finding. And it's pretty accurate. It's pretty accurate because the math says that the half-life of a certain element is based on whatever equation that chemistry, quantum physics, nuclear physics has given them. They use math to create an absolute of their observation, and it is in that way that scientists know how old the Earth is. The formation of the Earth itself began at the beginning with the Big Bang. Whether you believe in the Big Bang theory or religion, I believe they're the same thing, or at least that they're trying to describe the same thing. You understand that this is how the process went. In the beginning, God created the heavens and the earth, and the earth was void without form, etc., etc. I don't remember exactly. Scientists say, in the beginning, there was a singularity event that gave birth to the existence. That from nothing, everything was created. Science suggests the same thing. I'll give you my 2 cents on how the Earth was formed. 14.75 billion years ago, in existence, which is static dimensional coordinates governed by dynamic forces, the laws of physics came into being, and the universe as we know it was born. From existence, everything that we know was reshaped into what we see today. The early universe was filled with nothing but hydrogen and helium. The hydrogen and helium combined under electromagnetic, gravitational forces, the strong nuclear force and weak nuclear force, to form stars. These stellar bodies, under their massive gravity, compressed the early chemical elements of hydrogen and helium to form the heavier elements, up to hydrogen. The formation of this process created energy, but once iron was formed, this process lost energy. And this loss of energy was the death of the type 1 stars. The death of the type 1 stars, the gravitational compression against the opposition of magnetism created the actual explosions that are the death of type 1 stars, also known as supernova explosions. These supernova explosions created all the elements above hydrogen. This is important because a star cannot, as it's been described by science, form elements higher than iron. But the elements higher than iron do exist. The only explanation science gives is that they must have been formed in supernova explosions. This is important when understanding the evolution of the universe, because type 1 stars could not have had planets as we know them around them. They could have had gas giants, but they could not have rocky planets, because no element higher than iron could have existed in orbit around a type 1 star. Type 2 stars form from the remains of type 1 stars, and that is how the Earth, the small rocky planets, are able to form around a star, because the rocky elements have to be present during the formation of the type 2 star for the type 2 stars to have the rocky planets orbiting around them. This is formed in the accretion disk of the formation of type 2 stars. From the type 2 star remains in the formation of the type 1 star, the Earth was born. The Earth was born from the heavier elements, and the lighter elements, water, hydrogen, helium, rained down on the Earth and created the oceans and all of the gases in the atmosphere. But the Earth itself, being void and without form, was a ball of molten lava. This ball of molten lava is the first stage of the geographical cycle, which is indigenous rock. Because the Earth, as a ball of lava, not as a ball of hydrogen, but as a ball of lava, formed a solid crust, which is the surface of the Earth that we walk around on. And on that surface, which was pure indigenous rock in the beginning, some 4.5 billion years ago, is the oldest substance known to humankind as far as geography goes. When the Earth was forming from this lava, and it cooled and coalesced 4.5 billion years ago, the remains of that rock can still be found by scientists today. Chances are they find it at the bottom of the ocean, but it's still there. That particular substance, that strata, gives rise to sedimentary rock and metamorphic rock. And I can go on forever, but YouTube gives me limitations. And with that said, this is Paul Emerson, and that is my 2 cents. The formation of the Earth.